Hello. Today I like to explain something regarding the SIKA EC7. This is a process multimeter, and a process multimeter is an DMM, that means a digital multimeter in combination with a multifunction process calibrator. That means this device, that means the EC7 can even generate signals. And the setup of the device is a large display on the top, different operating buttons on this side, and a selector switch to select the desired functionality. And today I like to explain something regarding the functionality to simulate a transmitter. That means to have an 420 milliamp loop, and the loop is powered by an external power supply. So that means I have an external power supply. The plus is here. I give the plus here to my loop, and this is my loop with an amp meter, and from the amp meter I use this terminal for the simulation of the transmitter functionality. And transmitter function simulation of transmitter functionality means that the EC7 generates a 420 milliamp signal like a transmitter. For example, like a temperature transmitter or a pressure transmitter, whatever. So that means to close the loop, I go to the minus of the external power supply. So I select the milliamp DC in voltage, and on the display you can see milliamp DC, the simulate mode, and the source. That means we will generate a signal. Currently my current from the into the loop caused generated by the EC7 is switched off, and 4 milliamp is related to 0%, and you see no current is in the loop, and so it's 0. Now I switch on, and that means now the EC7 is generating a 4 milliamp signal into the loop, powered by an external power supply. So you see in the loop now we have the 4 milliamps indicated by my amp meter. And if I like to change the value, I can do this very easily. I increase the value, and then I see 6.2%. I increase a little bit higher, for example, to 8 milliamps. So that means 25%. And here I even see the 8 milliamps in the loop. Yeah? And I can even decrease the value to 0, and then I see minus 25, because the basis value is all the time the 4 milliamp, and if I have 0, then I'm minus 25% below 4 milliamps. So I switch off the loop, and then I see again no current in the loop. Different other functions. I can select, for example, 25 or 100%. I go in this way. I select in the display you will see 25. So that means 4 milliamps. I power on the loop, and then I see in the loop the 4 milliamps. And now if I increase the value in steps of 25%, I see 8 milliamp, 12 milliamp, 16 milliamp, 75%, and 20 milliamp is related to 100%. So that means I can increase or even decrease in steps of 25%. And it will stop at 4 milliamp. And even if I go the opposite side, increasing, it will stop at 100%. So I can change the values in steps of 25%. That means in 4 milliamps from 0 to 100%. I switch off the current, so no current in the loop. I operate again this operating button, change over to 100, and then 100 is indicated. I switch on. I have the 4 milliamp, and if I increase now, I see immediately 100%, and 100% is related to 20 milliamp. If I decrease, I go down to 0. If I increase, I go up to 100%. I switch off again the loop current. The loop current is back to 0. And now I like to show ramp function and a step function. I select this, and then you see the ramp is increasing and decreasing all the time, and it's in a slow speed. The S is indicating slow. Slow means it takes approximately from 4 to 20 milliamp a time of 30 seconds. So that means I select the ramp, the slow version. I switch on the current into the loop. We have the 4 milliamps in the loop, and I press start. And now it's increasing. You see the current in the loop is increasing, and now from 4 to 20 milliamp it takes approximately 30 seconds. And if you reach the 20 milliamp, then it will decrease down to 4 milliamp. So now we reach the 20, and now it's decreasing. I stop it. Yeah, and then run is off. I can start it again, and then the process is starting from the point where I stopped it. I stop it again, and I switch off the loop current. Current is 0. I select another function, and this is the same function as before, but with fast. And that means now from 4 to 20 milliamp, it takes approximately 15 seconds. I switch on my loop current, 4 milliamp. I start the process, and now it's increasing from 4 to 20 milliamp in a time of approximately 15 seconds. And if you reach 20 milliamp in the loop, then it change over and decrease the milliamp value. Stop the process, start the process, stop the process, switch off. So, and then I have again 0 in the 0 milliamp in the loop. And yeah, that's all what I like to explain.